So this slide marks the beginning of part 2 of our final exam review. We need to find the slope of the line through the given points. What is the formula for slope? What's the formula for slope? No. M equals y2 minus y1 over x2 minus x1. All right, so there's my formula. Go ahead and make your substitutions and solve for the slope. All right, so we need to identify our x1, y1, x2, y2, and that's exactly how the sequence goes. x1, y1, x2, y2. All right, so if you're confused about that, that is something you absolutely have to memorize. That will really mess you up on your final if you don't understand that sequence. All right, so now let's go ahead and make our substitution. 6 minus 0 over negative 1 minus negative 3. You've got to catch those double negatives. You're already subtracting, and when you plug in a negative, that's a double negative, which changes to a what? Positive. So 6 over 2 is going to be 3 or 3 over 1. Either answer will be acceptable. If you say 6 over 2, that's not going to be full credit because you need to do some type of reducing. All right. Now on the second one, we again make our substitutions, and then there's no reducing. Don't change it to a mixed number. It's got to be rise over run. It's just 5 over 3. Any questions on slope? All right, good. So no questions on slope. So now let's look at, let's see what's next. Finding the slope and the y-intercept. Okay, so now it says find the slope and the y-intercept. Well, the first thing I have to do is get this equation in function form. I can't just say, oh, well, the number attached to my x, that's my slope, and the number that's by itself, that's my y-intercept. I have to first write this equation in function form, or slope-intercept form, whichever term you want to use is the same thing. What is slope-intercept form? Y equals mx plus b. So go ahead and switch around this equation so that we have y equals mx plus b. So we're going to write it in slope-intercept form, subtract 3x. Now, out of these two terms, 5 and negative 3x, which one comes first? The x term. Very good. The x term comes first. That's slope-intercept form. Then I divide everything by 2, and y equals negative 3 over 2x plus 2.5. But that's not the answer. What did they ask you to find? Find the slope and the y-intercept. They didn't say write it in slope-intercept form, but you have to do that to find the slope and y-intercept. What variable do we use to identify the slope? What variable? M. It's an odd variable. Has nothing to do with the way slope is spelled, but M is our variable for slope. What is our slope? Negative 3 over 2, not the x. Only the coefficient attached to the x, negative 3 over 2. What variable do we use for y-intercept? Again, very odd variable to choose, but nonetheless, b. B is the variable we use for y-intercept, 2.5. You could say 5 over 2, but what you cannot say is 2.5 as a mixed number, okay? Again, we don't graph that way. So our m and b values. I want you to go ahead and do the second one on your own. All right, so what do I do first to write this in slope-intercept form? What do I do first? 4x. Subtract 4x from both sides. All right, and you get negative 10y equals negative 4x minus 9. So now you can tell what the slope is? What do you do now? Divide everything by negative 10. All right, and you've got to make sure that you reduce correctly. All right, so m equals what? 2 over 5. And b equals 9 over 10. All right, who got those right before I did? Anybody get those right? Okay, so identifying the slope and y-intercept, you've got to write it in function form first, and then you can identify. Now we're going to test solutions. So in this slide, I have the ordered pair 1, -1, and they want me to tell whether or not it's a solution to the linear system. Basically, we're taking that ordered pair and we're plugging it in to both equations. You can't just say yes. You've got to have work, okay? So just simply answering yes or no is not sufficient for this type of question. You have to actually show the substitutions and then answer yes or no. All right, so have we made substitutions? So when we make our substitutions and we have to evaluate both sides, we do clearly see that the ordered pair is a solution for both equations. But this is not your answer. This is your work. What is your answer? Yes. Your answer is yes. So if you do all the work on your test and you forget to say yes or no, you're not going to get full credit. Okay? Your work is there. That's your proof. But then your answer is yes. Good? Understand? All right, so testing solutions. Now let's graph a function. In this chapter, we learn multiple ways to graph a function. I'm going to review 2 of them with you. The first and the most common method is to use, what is this? It's my input-output table, because I have to have ordered pairs. You don't have to graph this. I'm going to walk you through it, but you need to know how to do this for your final. So for an input-output table, the reason I'm doing this is because I need ordered pairs to graph this function. Well, what's my standard domain set? You can write this part down on your papers. You just don't have to graph it. What's my standard domain set?
-2, -1, 0, 1.
Very good. -2, -1, 0, 1, and 2. Y'all remember that? Why can I not use that domain set on this function? Andrew?
It's a fraction.
Because it's a fraction. Since it's a fraction, I'm going to look specifically at my denominator, and that will help me decide my input values. Write them on your paper. Write them on your paper. See if you can figure out what input values you should put in your XY table. Okay, and then we'll talk about it in just a second. What are my input values?
-4, -2, 0, 2, 4.
Very good, because I need 2 negative values. And why would I not use like -20? Because it's going to make my graph really big. Even though that's a multiple of 2, that's still going to make my graph really big. So when I plug those numbers in, I get an output of 9, 6, 3, 0, and -3. Now, for each one of these, now these pairs form ordered pairs that I can graph on the graph. So my first ordered pair, -4, 9. All right, I'm going to come over here and I'm going to plot it. So which way would I go on X, left or right? I go left, how many? 4, and then up or down 9? Up 9. So whatever sign that number is, that's what tells me, left or right, up or down. All right, and then what? Where do I go now? Left 2. Come on, guys. Left 2, up 6. Then what? 0, up 3. Then what?
Right 2.
Very good. 2, 0. Then what?
Over 4, down -3.
4, 3. Okay? And then I just draw my line straight through. Another way that you can graph this and bypass the input-output table, you are not going to be counted off on your test, on your final exam, if you do not have an input-output table, because there is another way you can graph this. However, I think input-output table is pretty easy, and I would encourage you to do that way. Another way you can graph is by simply looking at the function, and more specifically, looking at the y-intercept. The y-intercept, since it's +3, tells me that the line will cross the y-axis at a value of 3. And it'll always be that. So you could just look at the y-intercept. It's a 3, plot a point on the 3. Then you can follow the slope, -3 over 2. Which part is negative, your rise or your run?
Rise.
Which part is negative?
Rise.
My rise is negative. So from this point, once I plot it on my y-intercept, do I go up 3 or down 3? Down 3, and how many do I go over?
2.
over 2. And look, ironically, there's a point already there. Down 3 over 2, there's already a point there. So you could plot these 2 points, draw your line through, and you graph the exact same function. So if you don't remember that, you could go back and watch that video. That's using, what is it called? Maybe using intercepts to graph a function. But if you don't get that, use the input-output table. No big deal. Okay, either way is fine as long as you know how to graph the function using one of those 2 methods. All right, so that's it for graphing functions. Let's see what's next. We've got solving, looks like solving equations. Solving equations. What's unique about this is my equations have a what? What do my equations have attached to them? The variables. Exponents. So what do you do to get rid of that exponent? Don't say it out loud. Go ahead and try to solve the first one. 9w squared equals 225. So in the first one, 9w squared equals 225. What do I do first? What do I do first? I've got to get w by itself. Do I take the square root first? No. I need to divide both sides by 9. Now that all I'm left with is w squared, how do I get rid of the exponent? I just said it. You take the square root. Take the square root of both sides and w equals 5. And if you write this on your exam, it's actually not correct because I forgot something. Does anybody know what's missing?
The square root thing.
Nope. Nope. I did the square root. The positive negative. The positive negative. Because my answer is both positive and negative because what's negative 5 times negative 5? Positive 25. And then 9 times 25 is 225. Whether it's a positive or negative version, they both work out. Okay, so that's why. W equals positive negative 5. So let's just look at the second one. It's so easy that we could just answer this verbally. What would I do to both sides on the second one? Square root. What's the square root of 144? 12. And what would be my answer? Positive negative 12. All right, go ahead and do the third one now. The third one is going to take a little bit more work than that. Not much. Not much. All right, go ahead and do the third one. All right, so 2n squared equals 72. Divide both sides by 2. N squared equals 36. What do I do to both sides? Square root it. What's my answer? Positive negative 6. Who got positive negative 6? Awesome. Okay, so that's solving equations with your exponents with the variables. All right, now let's simplify expressions. When we're simplifying these expressions, they're not perfect squares, like square root of 25 is 5. It's not going to be that cut and dry. So although I can't take an even square root of 63, there might be a factor of 63 that is a perfect square. And if there is, I have to take the square root of that number and then leave underneath the radical anything that is not a perfect square factor. All right, so go ahead and try to simplify these expressions, and we'll talk a little bit more in depth about it in a second. So anybody think of any perfect squares, factors of 63? 9. Very good. 9 times what? 7. So what's the square root of 9? 3. So that's why my answer is 3 square root of 7. Who got 3 square root of 7? Very good. What about square root of 11 over 64? Well, technically, I can take the square root of top and bottom. Are there any perfect square factors in 11? No, but what about 64? 8. So that's why it's square root of 11 over 8. Did you get that for number 2? All right, finish up number 3. Pull out your perfect square factors and leave everything else underneath. Any perfect square factors in that one? And 147 x squared y squared? Any perfect square factors? What? Nope, a perfect square factor. That's a square root. Where's your calculator? Well, so if you take the square root of 147, what does it give you in your calculator? 7 square root of 3. So if a 7 is on the outside of the radical, what does that mean? It means that what? 49 was a perfect square factor. 49 times 3 is 147. So when I say perfect square factor, I mean, okay, well, if there's a 7 on the outside, it means 49 was on the inside. Your calculator did it for you. Does that make sense? Okay, so 7 square root of 3. But what do I do with my variables? X squared, y squared. Can I pull those out? For every multiple of 2 in your exponents, you can pull out 1. So since they're both squared, you can say 7xy square root of 3. Now, what if it was x to the third? What would it be? You know, that's to the third. So you can pull out, there's 2, so you can pull 1 out, and how many does it leave underneath? 1. You're going to see that as you move into Algebra 1, those exponents underneath the radical, they're going to start getting bigger. So for every multiple of 2, you can pull out 1. So what if it was x to the fourth? How many would you pull out? X squared. If it was x to the fifth, how many would you pull out? 2. And how many would stay? 1. Okay, so if that goes over your head, that's okay. All you need to understand is the x squared. Because there's 2, you can pull 1 out. All right, so that's simplifying the expression. Now let's move on to Pythagorean Theorem. Pythagorean Theorem. We're only going to do one of these. Okay. What's the Pythagorean Theorem?
A squared plus b squared is c squared.
Very good. Plus b squared equals c squared. So we're going to do the first one. A equals 28. C equals 53. Make your substitutions and solve. Okay, a squared plus b squared equals c squared. I make my substitutions. I subtract. And then I take the square root. Who got 45? Who got 45? Very good. Pythagorean Theorem. It is not positive negative because it's a measurement. Because it's a triangle, measurements can't be negative. That's the only reason. All right, now let's do distance and midpoint, and we'll be done. Okay, so distance, we're only going to do the first one. Okay, we're just going to do the first one. I want to give you a minute to try to remember the distance formula before I give it to you. All right, we'll find the distance first. The distance formula is D equals square root x2 minus x1 squared plus y2 minus y1 squared. We make our substitutions. You must show that you must show your substitutions on your final. Formula substitutions. At this point, you can do your answer, although I recommend that you take it a step further and simplify a little more before you put it in your calculator. And now D equals 16 plus 9, which is the square root of 25, so it's 5. All right, who got 5? Anybody get 5? All right, so that's it for distance. And now we have midpoint. You have some midpoint problems on your final exam. Find the midpoint of the segment with the given endpoints. Again, we're just going to solve the first one. Both of them are the same thing, but for sake of time, we're just going to do the first one. Formula for midpoint, say it with me. M equals x1 plus x2 over 2 and y1 plus y2 over 2. I've had a lot of people in the past on the test and quiz when we had this, when we tested over this section, they did not write their answers as ordered pairs. This is an ordered pair, okay? And you must write your answer as an ordered pair. So make your substitutions and write your answer as an ordered pair. I'll give you another minute to finish. Make your substitutions. All right, and we simplified. Did you get 5-3? Who got 5-3? Raise your hand. All right, so that completes part 2 of our final exam review.